boys, check this out. So she's all hooked up. Happy days. It's running. Keeps smelling like a burning smell. I think someone's got a grass fire next door, but it's freaking me out. Yeah, so she's all running. Big contactors there, shunt, 48 to 12 step down converter. The 12 volt fuse block thing that's there. Yeah, she's all hooked up, running into here. So at the moment we've got we have got 1.34 kilowatt of solar coming in. It's 3 o'clock, so yeah, I think we got 2.8 on the roof at the moment of the bus. So probably not too bad for the time of day. So it's got 18 amps going to the battery, and then minus the load, it's sending 970, let's just call it 950 watts of solar power to the batteries, and the rest of that wattage is going probably into the house or the bus circuits to run like the fridge and the lights and stuff. So that's pretty cool. And then yeah, 18 amps going straight to the batteries. Oh, I'm going back the other way. Yeah, batteries are sitting at 53.8 volts. Max is 58 volts. Yeah, and that's a load 7%. So yeah, 250 watts load, which is probably just a fridge, I think, because it's been off for a couple of days, so it's probably chomping through it to try to get the fridge cool. Yeah, battery's got no load on the battery because it's all solar, so yeah, that's pretty cool. So come in here, let's go have a look inside. Have a gander. So here is the BMS. I've got to reset the state of charge because it's not 98%. I fucked up before and pressed the wrong button. So I think I've got the shunt around the right way. This is positive current coming into the batteries, so it'll have 18 amps coming in, 0.9 kilowatts coming in. Obviously, yeah, then there's nothing coming out of the batteries because the whole system's running on solar. So that's that. And if I press this button, shows my average voltage, temperature, minimum, min voltage, max voltage. So it's pretty good, not too bad. And there's all the cells. So there's a couple low ones down here. Yeah, but not that I know much about lithium iron phosphate cells, but they'll look to be pretty good as far as being close together. And then all these bars down here shows the cell voltages. So there's a couple there that are sort of just ticking orange, meaning that the BMS will be charging them. So the BMS will charge them, yeah, I think if it's 0.01 of a volt difference, they'll start to charge, or 0.1 of a volt difference. 0.1 of a volt sounds better. 0.1 of a volt, it'll start to balance them. So, yeah. And then, yeah, so if you if I hold it, all the settings come up. Pack capacity, state of charge warning, full voltage 58 volt, warning current. So if it's drawing more than 100 amps, it'll warn me. If it goes over 200 amps, it'll trip. 16 cells, shunt size 200 amps, minimum voltage 2.5 volts, max voltage 3.7. Dynamic, so that's how it balances each cell. Hysteresis. Anyway, I don't have this set up at the moment. This, yeah, it runs through it, but anyway, I don't need it. Min temp, max temp, I'm just going to see how that goes. That's as per the cells. This is for the CAN bus setup if you want your BMS to tell your charger what to do, so this isn't applicable for our setup. And that's a stationary mode that is linked with the hysteresis, whatever that word is. Anyway, Night brightness, buzzer on, yes. Use hard Fahrenheit, no, percent. Actually, I wonder if I change that amp hours. Yeah, still wrong. Anyway, so that's it. That's the setup. Pretty cool.